Hello, welcome to another module in this online course Strategy and Introduction to Game Theory. We are looking at Bayesian games in the past couple of modules, right. We have looked at two examples of Bayesian games. We have looked at a Bayesian version of the battle of sexes, and we have also looked at another Bayesian game, that is a yield versus fight game between two people, right. Now let us look at another example of a Bayesian game, an interesting example. Let us look at a Cournot game. Remember, we have already looked at a Cournot game, but now let us look at a Bayesian version of the Cournot game. So let us look at a Bayesian Cournot game or a Bayesian version of the Cournot game. Remember, the Cournot game models market competition between two firms F1, F2. So, the Cournot, it is a market game which models the competition between two firms F1 and F2. However, now let us introduce uncertainty into this game in terms of the uncertainty in the production costs of firm 2. So, let us say that firm 1 has a production cost of C per unit. However, firm 2 is of two types. Right, firm 2 of type low has a production cost. So, there is firm 2 of type low which has a production cost of half C, and probability of low equals half, and firm 2 of type high has a production cost of C and the probability of P high equals half. So, we are saying there are two types of firm 2, right. Firm 2 can be of type low, which has a low production cost of half C per unit, and firm 2 can be of type high, which has a production cost of C per unit, and the probability of each of these types of firm 2 is half each. That is, firm 2 can be of type low with probability half, and firm 2 can be of type high with probability half, right. While type low has a production cost half C, type high has a production cost of C, right. And the inverse demand curve, remember we will assume the same, the inverse demand curve that is the price per unit P, that is the price per unit P as the function of the quantities Q1 and Q2 produced by firms 1 and 2 is, well, we can model that as A minus Q1 plus Q2, right. So, this is the price P, which is A minus Q1 plus Q2 as a function of Q1 is quantity firm 1 and Q2 is the quantity produced by firm 2. So, Q1 and Q2 are the quantities produced by firm 1 and firm 2. So, inverse demand curve, which gives the price as a function of the quantities, is basically the price P equals A minus Q1 plus Q2. That is, what we are saying is that these quantities are closely related. Remember, in the Cournot game, both the firms are producing substitutes or strategic substitutes, where one quantity can be more or less readily substituted for the other. Therefore, the price decreases, price per unit decreases with the total quantity Q1 plus Q2 produced by both the firms. As Q1 plus Q2 is increasing, the price P, which is equal to A minus Q1 plus Q2, is decreasing, right. So, this is the inverse demand curve which gives the price as a function of the quantities Q1 and Q2. Now, therefore, the payoff to firm J, therefore, the payoff to each firm J equals price per unit times the quantity minus cost of production, which is equal to, remember the price is A minus Q1 plus Q2 times the quantity Qj produced by the firm J minus C, the cost Cj times Qj, right. The payoff to each firm J is A minus Q1 plus Q2, which is the price, times Qj, the quantity, this is the total revenue, minus the cost, which is Cj times Qj, where Cj is the cost per unit to firm J, right. Now, what we want to do is we want to find the Bayesian Nash equilibrium of this game, right. What we want to analyze, this is a Bayesian game, since there is uncertainty regarding the payoffs of firm 2, regarding the types of firm 2 and payoffs of firm 2. Remember, we said that firm 2 can be of two types, of type low or type high, right. Each type occurs with probability half. This is not known to firm 1. Firm 1 does not know which type of firm 2 he is playing against, right. So, there is uncertainty regarding the type of firm 2, hence the payoffs involved, right. So, this game is Bayesian in nature, since there is uncertainty, right. So, we want to analyze the Bayesian Nash equilibrium for this game. Let us start by assuming the quantities produced by the firm 1 and each type of firm 2. So, let us say firm 1 produces Q1 and firm 2, well, firm 2 there are two types. So, let us say firm 2 of type low produces Q2L and firm 2 of type high produces Q2H. So, there are two types of firm 2, right. We are saying firm 2 of type low produces a quantity or chooses the strategy or action Q2L, and firm 2 of type H, high production cost, chooses the quantity Q2H, right. So, this is these are, so we are ascribing quantities to the different firms. We are saying firm 1 is producing Q1, firm 2 of type low is producing Q2L, and firm 2 of type H is producing Q2H, right. And therefore, the various payoffs are given as follows. The various payoffs to firm 2, for instance, the payoff to firm 2 payoff to firm 2 of type L is equal to, well, A minus Q1 plus Q2L times Q2L, price times the quantity minus the cost. Remember, the cost per unit is only half C for firm 2 of type L. So, this is minus half C times Q2L, right. So, this is the price, which is A minus Q1 plus Q2L times the quantity Q2L, this is the revenue, minus half C, which is the price per unit, times Q2L, which we can simplify as A Q2L minus Q1 Q2L minus Q2L square minus half C Q2L. So, we have derived the payoff, we have derived an expression for the payoff for firm 2 of type L. What do we have to do now? We have to differentiate this expression, set it equal to 0 to find the best response of firm 2 of type L. right. So, we want to find the best response of firm 2 of type L. Therefore, I am going to differentiate this expression and set it equal to 0. When I differentiate this expression and set it equal to 0, I get A, I am differentiating with respect to q to L, minus q1 minus twice q to L minus half C equal to 0. So, I have A minus q1 minus 2 q to L minus half C equal to 0. So, therefore, we have the best response q to L star equals A minus half C minus q1 divided by 2, right. So, what have we done? We have first derived an expression for the payoff of firm 2 of type L as a function of the quantity q1 produced by firm 1 and q2 L produced by firm 2 of type low. Then we have differentiated this with respect to q2 L, set it equal to 0 to find the maximum, that is we are finding the best response, that is we are finding the q2 L star corresponding to which this payoff is maximized, and that expression we have shown is q2 L star equals A minus half C minus q1 divided by 2, right. Now, similarly payoff to firm 2, right, payoff to firm 2 or payoff to firm 2 of type H is, well, the price which is A minus q1 plus q2H. Remember, firm 2 of type H produces quantity q2H times q2H minus it has a production cost of C, therefore, C times q2H, right. So, payoff to firm 2 of type H is the price which is A minus q1 plus q2H times q2H, the quantity, minus the cost per unit is C, because firm 2 of type H has a cost C times q2H, which is equal to A times q2H minus q1 q2H minus q2H square minus C q2H. Now, again to find the best response q2H, we can differentiate it and set it equal to 0 to find the q2H corresponding to which this payoff is maximized. If I differentiate this with respect to q2H, I have A minus q1 minus 2 q2H minus C equals 0. So, I have A minus q1 minus 2 q2H minus C equals 0, which means q2H star equals, well, A minus q1 minus C by 2. This is the best response. What is this q2H star? This is the best response of firm 2 of type H. So, the best response q2H star of firm 2 of type H is A minus q1 minus C divided by C as a function of the quantity q1 provided or manufactured by firm 1. So, what have we done? We have derived q2L star, which is the best response of firm 2 of type L, and we have also derived the best response q2H star of firm 2 of type H. Now, we have to derive the payoff of firm 1. Remember, for firm 1 there is uncertainty regarding the type of firm 2. So, for firm 1 we have to compute the average payoff, right. So, firm 1, payoff of firm 1 payoff of firm 1 corresponding to type low of firm 2 is firm low, firm 2 of type low is producing Q2 low, the payoff corresponding of firm 1 corresponding to that is A minus, well, Q1 plus Q2 low price times Q1 minus cost C times Q1, right, because Q firm 2 of type low is producing Q2 low. Therefore, price is A minus Q1 plus Q2 low. Therefore, revenue is A minus Q1 plus Q2 low times Q1 minus the cost, which is C times Q1. Similarly, payoff of firm 1, similarly payoff 2 firm 1 corresponding to firm 2 of type H is, well, A minus Q1 plus Q2 H times A minus Q1 plus Q2 H times Q1 minus C times Q1, right, which is the price, which is A minus Q1 plus Q2 H times the quantity Q1 minus C times Q1. Therefore, the average payoff, remember the probability of firm 2 of type low and firm 2 of type high is half each. Therefore, average payoff of firm 1 is half times payoff from firm 2 of type low, which is A minus Q1 plus Q2 low times Q1 minus C times Q1 plus half times payoff corresponding to firm 2 of type high, which is A minus Q1 plus Q2 high into Q1 minus C times Q1. And now what I can do is I can differentiate this with respect to Q1, differentiate this average payoff of firm 1 with respect to Q1 to find the best response Q1. So, differentiate, let me write that, differentiate with respect to Q1 and set equal to 0 to find the best response Q1, right. And when I differentiate and set this equal to 0, I will have, you can check, half of A minus 2 Q1 minus Q2L minus C plus half of A minus 2 Q1 minus Q2H minus C equal to 0, which means I will have, solving this, I will have 2 Q1 star equals half times A minus C minus Q2L plus half times A minus C minus Q2H. Therefore, I can write Q1 star equals, well, I can write this as A minus C by 2 minus 1 by 4 Q2L plus Q2H. So, what have we derived? We have derived Q1 star, which is the best response. By differentiating the payoff, average payoff of firm 1, which is a function of Q1, by differentiating this with respect to Q1 and setting it equal to 0, we have derived the best response Q1 star of firm 1, right, as a function of the quantities Q2L and Q2H produced by firm 2 of type low and high respectively. So, this is the best response. best response of firm 1, right. This is the best response of firm 1. How do you find the Bayesian Nash equilibrium? Well, at Bayesian Nash equilibrium, each firm of each type is playing its best response. Therefore, we will have firm 1 producing Q1 star, firm 2 of type low producing Q2 L star, firm 2 of type H producing Q2 H star. Therefore, if you look at this, firm 2 of type low will be producing Q2 L star, firm 2 of type H will be producing Q2 H star, and firm 1 will be producing Q1 star. Therefore, now we can write the equations for this as, well, everyone will be producing their, everyone will be playing their best responses. So, we have Q2 L star equals, well, A minus half C minus Q1 star divided by 2 and Q2 H star equals A minus Q1 star minus C divided by 2 and also Q1 star equals half A minus C minus 1/4 Q2 L star plus Q2 H star, and from the previous equations given here we can substitute the expressions for Q2 L star and Q2 H star in this, and we get half A minus C minus 1/4, well, Q2 L star equals A minus half C minus Q1 star divided by 2 plus A minus C minus Q1 star divided by 2. So, we get an equation in Q1 star. So, this is an equation for Q1 star, and we can solve this, we can obtain, by solving this one can obtain Q1 star equals A minus phi C by 4, phi C by 4 divided by 3. So, this is the best response of quantity of firm 1, right. This is the best response quantity of firm 1, right. Now, we can substitute this Q1 star in these expressions, we can substitute this Q1 star in these expressions for Q2 L star and Q2 H star to derive the expressions for Q2 H star and Q2 L star. So, we have Q2 or Q2 L star equals A minus half C minus Q1 star divided by 2, which is A minus half C minus 1/3 A minus phi C by 4 divided by 2 equals A by 3 minus C by 24, that is Q2 L star, that is the best response of, or the Nash equilibrium quantity of firm 2 of type low. And similarly, Q2 H star is equal to, once again substituting Q1 star, we have A minus C minus Q1 star divided by 2, which is equal to A minus C minus 1/3 A minus phi C divided by 4 divided by 2, which is equal to A by 3 minus 7 C by 24. Therefore, we have derived the expressions for Q1 star, Q2 L star and Q2 H star. So, we have derived the Bayesian Nash equilibrium, of the Cournot, Bayesian Nash equilibrium of the Bayesian version of the Cournot game is therefore, well, Q1 star equals A minus phi c by 4 divided by 3, Q2 L star equals A by 3 minus C by 24, and Q2 H star equals A by 3 minus 7 C by 24. And what are this? This is the quantity of firm 1, this is the quantity firm 2 of type low, and this is the quantity of type H. So, we have derived the Bayesian Nash equilibrium or the BNE of the Bayesian version of the Cournot game. What have we derived? We have derived the equilibrium quantities of each firm of each type at the Bayesian Nash equilibrium. We are saying that the quantity produced by firm 1 in the Bayesian Nash equilibrium is A minus 5C by 4 divided by 3. The quantity produced by firm 2 of type low is A by 3 minus C by 24, and the quantity produced by firm 2 of type H is A by 3 minus 7C by 24. Therefore, we have analyzed a Bayesian version of this Cournot game in which there is uncertainty regarding the type and payoffs of firm 2, and what we have derived is we have derived the Bayesian Nash equilibrium of this game by computing the quantities produced by each firm of each type at the Bayesian Nash equilibrium. All right. So, this concludes this example on a Bayesian version of the Cournot game. Thank you very much.